as an implicit function, and it wants us to find the equation of the normal. Now we know from C1 that the equation of the normal is the perpendicular to a tangent line. Oops. So this is my tangent line, then this is my normal. So if we can find the gradient of the tangent line, we can just find the negative reciprocal, which will get us the gradient of the normal. We've got the coordinate that we need. The coordinate is 2, 3. And so we could then use y minus y1 equals mx minus x1 to get the equation of that normal line. So that's my plan. Get dy by dx, work out the gradient of the tangent, work out the equation of the gradient of the normal, and then get the equation. So let's find dy by dx first. So we need to differentiate each part. Differentiating x squared is 2x. To differentiate this 3xy, I'm going to use the product rule. I'm going to differentiate this and leave this alone, which is just 3y, 3y. And then I need to leave the first one alone and differentiate the second one. And when we differentiate y with respect to x, we get dy by dx. So that's going to be 3x dy by dx. Here, we've got a 4y squared. We're going to use the chain rule on this. We're going to pretend this y is an x and differentiate it. If it had been an x, we'd get 8x. So we're going to get 8y. But then again, we need to times by the differential of what we pretended was an x. We pretended that y was an x, so we need to times by dy by dx. And that's going to equal 0, because when we differentiate 58, a constant, we get 0. So now we've got dy by dx, but we've got it in two places. We need to get it down to being in one place. So I'm going to factorise a dy by dx out of these two terms here. So we've got a 3x plus 8y here. I'm going to move these two terms without a dy by dx onto the other side. Just written y there, and that should just be 2x. So I've got 2x, take away 3y on the right hand side, and therefore dy by dx is going to be minus 2x minus 3y over 3x plus 8y. Now we want to find the gradient of the tangent at this point 2, 3. So at 2, 3, dy by dx, the gradient of the tangent, is going to be minus 4 minus 9 over 6 plus 24. So that's minus 13 over 30. And that's the gradient of the tangent. Therefore, the gradient of the normal is going to be positive 30 over 13. So now, finally, we can do y minus y1 equals mx minus x1. Notice it wants it in this form with a, b and c being integer. So I'm going to have y minus 3 equals 30 over 13 x minus 2. I'm going to times everything by 13 and expand these brackets here. So that's 30x take away 60. And then everything needs to be on one side. So I'm going to have 30x take away 13y, and I need minus 60 plus 39, which is minus 21, and that equals 0. So that's my final answer.